Hello guys, in today's video, we'll be learning how to add numbers in base 2. Let's get right into it. We have two methods that we employ when we want to add binary numbers, also known as numbers in base 2. The first method will be to perform the addition in base 2, and the second method involves converting the numbers to be added to base 10, performing the addition, and then converting the result back to base 2. So we have two examples here. We're going to solve these two examples using the first method, and then we'll go ahead and solve them with the second method as well. So to perform this addition, I'm going to write out the numbers just like we do when we want to add our regular base 10 numbers. So 1010 in base 2, and we're going to be adding that to 1101 in base 2. Put the addition sign here. Now it's pretty straightforward when you have 0 and 1. We know that 0 plus 1 will give us 1. Here also 1 plus 0 will give us 1. 0 plus 1 will give us 1. These are all straightforward addition. Now we have 1 plus 1, which is going to give us 2. We already know that in binary or in base 2, we don't use the digit 2. The only digits that are allowed are 0 and 1. So every time you perform an addition and you encounter a number that is neither 0 or 1, you have to do a conversion of that number from base 10 to base 2. So in this instance, we have 2. We're going to convert 2 to base 2. If you are not conversant with conversion of numbers from base 10 to base 2, please check out our previous video on that topic. So I'm just going to come down here and do a conversion of 2 from base 10 to base 2. So just like we do, I'm going to be dividing 2 by 2 repeatedly till I get 0. So 2 divided by 2 will give us 1, remainder 0. 1 divided by 2 will give us 0, remainder 1. Now remember that when you do this conversion, you take your remainders in this direction, from down to up. So this is going to be, we know that 2 is equals to 1, 0 in base 2. So if you perform an addition, like when you have base 10 addition, for example, if you say 6 plus 6 and you get 12, you know you're going to write 2 and carry the 1 over. So it's the same thing that applies when we have a 2-digit answer here. We have 1 and 0. It means we are going to write 0 and carry 1. In this instance, since there's no other digit to the right to perform a carry, we're just going to write the answer here as 0, 1, and then indicate our base 2. So that is how to add numbers in base 2. Additions of zeros and 1 are pretty straightforward, but in the event that you perform your addition and you get 2, 3, 4, or 5, or whatever it is that you get as your answer, go ahead and do the conversion of that digit to base 2, just like we did with 2 here. Then you're going to write the first digit and do a carry of the second digit. Or if you have 3 digits in your answer, you're going to write the first one and do a carry of the other 2. Let's go ahead and try our second example. In this instance, we have 1, 1, 1, 1, and we have 1, 1, 0. Both of them are in base 2, and we're going to be performing an addition here. So 1 plus 0 will give us 1. That's pretty straightforward. We have 1 plus 1, and just like in the first one, we know that 1 plus 1 will give us 2. And when we convert 2 to binary, what we are going to get is 1, 0 in base 2. So in this instance, I'm going to write the 0 and I'll carry the 1. This 1. I'll carry it. So now that leaves us with 1 plus 1 plus 1. And we know that 1 plus 1 plus 1 will give us 3. And in binary, we cannot write 3 here. We know the only numbers that are allowed are 0 and 1. This means that we have to do a conversion of 3 to base 2, just like we did for 2 in this instance. So I'm going to come down here and I'll do that conversion. I'm going to write 3 and I'll be performing a repeated division of 3 by 2. 3 divided by 2 will be 1 remainder 1, and 1 divided by 2 will be 0 remainder 1. We'll write it in this direction. In this case, it doesn't matter since it's 1 and 1 anyway. So we know that 3 is equals to 1, 1 in base 2. So I'm going to write 1, which is this one here. And then I'll carry the other one up. And then we're going to have 1 plus 1, which brings us back here. We already have 1 plus 1 will give us 2, and 2 will give us 1, 0 in base 2. So I'm going to have to write 0 and 1. And this is the result of our addition using the first method. Now let's go ahead and perform addition of binary numbers using the second method. And like I said earlier, this method involves converting these numbers from base 2 to base 10, performing the addition in base 10, and then converting the numbers back to base 2. So let's start with our conversion. Now, if you don't already know how to convert numbers from base 2 to base 10, please check out our videos on conversion of binary numbers to numbers in base 10. So I'll start with 1010 in base 2, the first number here, and I'm going to write the powers just above it. We have 0, 1, 2, and 3. And then we'll expand by saying 1 times 2 raised to the power of 3. 1 is from the number here, 2 is the base, and 3 is the power we wrote above 1. I'm going to do the same for the rest of the numbers. I will have plus 0 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. Next, I'm going to handle the powers. We have 1 times 2 raised to the power of 3 is going to give us 8. That's 2 times 2 times 2. Plus 0 times 2 raised to the power of 2 will give us 4. Plus 1 times 2 raised to the power of 1 will give us 2. Plus 0 times 2 raised to the power of 0 will give us 1. Next, we are going to multiply. We have 1 times 8, which will give us 8, plus 0 times 4, which is 0, plus 1 times 2, which will give us 2, plus 0 times 1, which will give us 0. We'll add 8 plus 2, and it will be equals to 10. We'll do the same for the second number here, 1101 in base 2. So I'm going to write 1101 base 2. I'll indicate the powers 0, 1, 2, and 3. Let's go ahead and expand. We have 1 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 0 times 2 raised to the power of 1, and then 1 times 2 raised to the power of 0. Let's go ahead and do the exponential. 2 raised to the power of 3 will give us 8, plus 1 times 2 raised to the power of 2 will give us 4, plus 0 times 2 raised to the power of 1 will give us 2, plus 1 times 2 raised to the power of 0 will give us 1. If we multiply, we get 1 times 8, which is 8, plus 1 times 4, which will give us 4, plus 0 times 2, which is 0, plus 1 times 1, which will give us 1. If we add them together, we have 8 plus 4, 12, plus 1, which will give us 13. Now, this means that 1, 0, 1, 0 in base 2 plus 1, 1, 0, 1 in base 2 can be expressed as 10 plus 13. Since 1010 in base 2 is equivalent to 10 and 1101 in base 2 is equivalent to 13. And if we add 10 plus 13, we're going to get 23. But this is the answer in base 10. We have to finish by converting this back to base 2. The question was given to us in base 2, so the answer has to be in base 2 as well. So to convert 23 from base 10 to base 2, we're going to keep dividing 23 by 2 by storing the remainder. 23 divided by 2 will give us 11, remainder 1. 11 divided by 2 will give us 5, remainder 1. 5 divided by 2 will give us 2, remainder 1. 2 divided by 2 will give us 1, remainder 0. 1 divided by 2 will give us 0, remainder 1. Remember that when we arrive at 0 here, we know that we have come to the end of our division. And also remember that when we do conversions from base 10 to base 2, we are taking our remainders and in this direction from down to up. So what this means is that 1, 0, 1, 0 in base 2 plus 1, 1, 0, 1 in base 2 is equal to 1, 0, 1, 1, 1 base 2. So you can see that this is the same answer we got when we solve this example using the first method. So whichever method is more comfortable and more convenient for you, please go ahead and use that. The downside to this method is that it's lengthy, as you can see. But if you are not comfortable with doing those additions directly in the base, then by all means use this method. The most important thing is that you get the correct answer. Now let's go ahead and solve this other example using the second method as well. So just like we did for the previous example, we'll convert both numbers from base 2 to base 10. We'll add them and then convert our answer back to base 2. So let's begin with 1, 1, 1, 1 in base 2. We'll indicate the powers 0, 1, 2, and 3. And then we'll expand. This will be 1 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. To do the powers here, we'll have 1 times 8 plus 1 times 4 plus 1 times 2 plus 1 times 1. So that's 2 raised to the power of 3, 2 raised to the power of 2, 2 raised to the power of 1, and 2 raised to the power of 0. Next, we'll multiply. 1 times 8 will give us 8. 1 times 4 will give us 4. 1 times 2 will give us 2. And 1 times 1 will give us 1. We'll add this. 8 plus 4 is 12. Plus 2 is 14, and plus 1 is 15. Let's go ahead and do the same for 1, 1, 0 in base 2. We're going to write the powers 0, 1, and 2. If we expand this, we'll get 1 times 2 raised to the power of 2. So that's each of the numbers here multiplied by the base and raised to the power written on it. So plus 1 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. The next step, we solve the exponential. We're going to get 1 times 4, which is 2 raised to the power of 2, plus 1 times 2, which is 2 raised to the power of 1, plus 0 times 1, which is 2 raised to the power of 0. Now, if we multiply this, we get 1 times 4 to be 4, 1 times 2 to be 2, and 0 times 1 to be 0. We'll go ahead and add this, and 4 plus 2 will give us 6. What this means is that 1, 1, 1, 1 in base 2 plus 1, 1, 0 in base 2 will be equals to 15 plus 6. And 15 plus 6 will give us 21. So to get our final answer, we have to convert 21 from base 10 back to base 2. And you already know how we do that, but if you don't, like I said earlier, check out our video on conversion from base 10 to base 2. So we're going to divide 21 by 2, and that's going to give us 10 remainder 1. 10 divided by 2 will give us 5 remainder 0. 5 divided by 2 will give us 2 remainder 1. 2 divided by 2 will give us 1 remainder 0. And 1 divided by 2 will give us 0 remainder 1. As always, remember that we're going to take our remainders from bottom to top in this direction as indicated by the arrow. So what this means is that 1, 1, 1, 1 in base 2 plus 1, 1, 0 in base 2 will be equal to 1, 0, 1, 0, 1 base 2. So that's it for this lesson, guys. I hope you enjoyed it. If you did, please check out our next video on subtraction of binary numbers. As always, I've got a bit of classwork here for you to try. You can attempt addition of these numbers on your screen using the both methods, and you can always feel free to submit it to the email or your screen. I'll be happy to go over them and send you feedback. That's it for this lesson, guys. Thank you for watching. Please do it to like, share, subscribe, and turn on the notification button so you know when we upload a new one. I'll see you in the next one. Bye.